Proportional Relationships, Lesson 6 notes. Example number 4. Jack and Jill are baking muffins. Each baker used a different way to show the relationship between the total number of muffins baked, Y, and the number of batches made, X. Who baked more muffins per batch? It's not asking you who baked more muffins, but who baked more muffins per batch. So underline that word per. So that means we need to find the unit rate. Let's start with Jill. Jill's is great because if you look at hers, it gave you an equation. And remember, when they gave you the equation, you want it in slope-intercept form. Slope-intercept form is y equals. Well, this equation is already y equals 16x. So there is zero work to do here. I know that the slope is the number in front of x. Therefore, the slope for Jill is 16, meaning that her unit rate is 16 muffins per batch. All right, so let's go up here. Let's write that again. So for Jill, her unit rate is 16 muffins per batch. For Jack, let's pick a point on the graph to set up our rate. Let's pick this point right here. Make that a little bit bigger. Okay, so that would be 30 muffins in 2 batches. So Jack's rate is 30 muffins in 2 batches. Divide that out to find the unit rate. 30 divided by 2 is 15. So Jack bakes 15 muffins per batch. So to do this problem, to figure out who baked more muffins per batch, we had to find the unit rate for each person. Jill's, it was nice and easy for us because they already saw for y, and it was the number right here in front of x. So she baked 16 muffins per batch. For Jack, we picked a point on the graph and set up a rate. The rate was 30 muffins, because remember, when you set up a rate, rates are always y over x. So I picked the point on the y-axis, which is 30, and put it over the point on the x-axis, which was 2. And then to go from rate to unit rate, we divide. 30 divided by 2 is 15. So Jill baked 16 muffins per batch. Jack baked 15 muffins per batch. The final answer is Jill bakes more muffins per batch. Now, we actually did more work on this problem than we needed to. We did more work on this problem than we needed to. I wanted you to find the rate on the graph by setting up a rate. I wanted you to find the unit rate by first setting up a rate and then finding the unit rates. But I'm going to teach you a little trick. You want to look for 1 on the x-axis. You want to look for 1 on the x-axis. Sorry, I want to use... if I draw a line up to my graph, it touches my graph at this point right here. Between 10 and 20 would be 15. If you look for 1 on the x-axis, then you don't have to do any work. Because remember, unit rate is per 1 unit. So if you have 1 on the x-axis and you draw a line up and it intersects the graph at a point where you can easily determine the y point, then you don't have to do any work. So here, I drew my line up and over, it's at 15, so I know that my unit rate is 15 muffins per 1 batch. And isn't that what we got? So technically, we really didn't need to do any work. So what I would like you to do is I want you to put a line like this, put no work needed. So again, if you find the 1 on the x-axis and it intersects where you can easily tell what the point is on the y-axis, no work is needed. Let me scroll up to this problem here. Notice how there's no 1 on the y-axis? Because there's, or sorry, x-axis. Because there's no 1 on the x-axis, I couldn't just draw a line up. I couldn't do that. There has to be a 1 on the x-axis. Okay? But I could have done it here. The traveling car problem, I could have gone 1 up to the point and over, and I would have gotten 50. And that's what we got the entire way through. So again, when you're given a graph, look for 1 on the x-axis. If that doesn't work, then set up a rate and divide to find a unit rate. Right, so that is it for example number 4. If you have any questions, let me know. Please make sure you've paused the video and get everything written down before you close the video. Okay, if you have any questions, let me know.